just try, we can make a video capture of the live footage, like example you present right now. And well, yeah, you can stay a bit on this slide just to remind ourselves. For now, the other one, the next one, please. Slide number 20. Now we will go the next slide. Okay, now. Let's imagine in the complex scenario Martina just described, we are about the time 8:20 when one particular technology enters, and it's the traffic modeling. So it probably gets some update from the time slot before the 8:15, like traffic analysis software gives us some up-to-date information about the current traffic. Hopefully before all energy collapses, we get some data from the sensors. So then the model starts, and first of all, the traffic model needs to be calibrated to the last known status of the traffic in the city. This is something we still work on, and I will speak about this later in detail in the task 5.5, I think. But for now, let's imagine the model is up and running, and we have prepared the presentation which Willem will show you how we can use such a model in the emergency situation. The purpose of this demonstration is to show you something in particular which we can have for the focus group, for example. And if you tell us like, okay, this sounds good, we are happy, but if you tell us it's completely wrong, we need to do it other way, we are also fine, because we know that this is not the way, and we move to next solution. So this is the purpose and setting the scene for Willem. So please.
So I'll be very brief. So we have like prepared a scenario in the city of Pilsen. So as Martina showed you the situation with the traffic, there was like the screenshot of the busy road. So this is like exactly kind of a situation that we would like to mirror within the emergency management scenario during a digital breakdown. So imagine there is a digital outage, traffic lights are not working, and emergency situations like a fire occurs in the heavily congested area. And this is and the issue and the challenges to navigate the emergency systems occurs. So that's what we are trying to solve. So I've prepared a short scenario. We have a closure here due to fire, and as there in the area there are also like roadworks, so the area is congested. And so imagine that the interventions in the area needs to be the traffic needs to be diverted. So for us it means a couple of traffic management measures, such as banning the roads, as you can see the road sign here, and also like banning the turns from the busy main roads, so there are no incoming traffic doing in the area. Within the same time, there is also like the calibrations running on the background, and this way we can ensure that the emergency services have a tool for the navigation, for example. So this way they can calculate the shortest path to the intervention area, and then to the, for example, medical facility. So I would like to show you how to ban these roads, and then I'll show you how it impacts the calculations of the shortest path. Or it doesn't have to be shortest path, obviously it's more like the fastest path. Yeah, so for this purpose, I have removed the measure of closing the road. So imagine there is a fire raging here in this area, and all these sections needs to be closed. So there is no traffic there, and to ensure the free passage for firefighters.
Basically, what this Wilhelm doing is he creates. We already had created a scenario, and now he puts particular traffic event into the scenario. In this case, it's closing the roads, but we can also alter like the amount of traffic coming or leaving particular space as well. But in this case, it's about completely closing the roads in the area. And now it took a while to recalculate the model, to take those measures into account, and in a while we will
So it's
see.
an optimization model running in the background.
Yeah.
Yeah. So we need to give it few more seconds, or in a case something happens, we do have prepared output, so we can get it. But that's the time we need to think about. Even for the crisis situation, it takes a while when the model is recalculated.
So how long was that? 30 seconds?
Yeah.
More or less.
Yeah. Unfortunately, the dynamic model we would need to use, it would be minutes we work on, because, yeah, I'll come to this later. This is just a static model, the easy one.
Alright, so now these roads are closed for traffic. It's like the visualizations is not showing yet, but so now the next step is to calculate the shortest path. I've chosen this area, so it's like conveniently close to the nearest firefighting facility, which is somewhere here. Yeah, so you can see the fire symbol. So now let's have a look how to get the fastest path to ensure the firefighters have a free passage. So let's
So now you're choosing two nodes.
yeah. Yeah, and like it would normally it would probably be better to go with the upper road, but since I put like the roadworks there, it gets like congested. That's why it's yellow and red here. So now, and they would have decision-making problems, which road is the fastest one, and obviously for these couple of meters it would like make like a couple of seconds difference. But if they would need to go much faster roads, obviously it creates a much higher amount of time that can be saved by having the optimal routing. So as the Tramod suggested to go this way to so this is the fastest one, and now they are also so that they should avoid the section with the roadworks. Now the model is the calibration is running on the background, and now we would like to shift the time, let's say for 15 minutes. Like we can our lowest step is out right now, but we will have it ready to have it lower for the purpose of emergency management scenario. So I imagine that ambulance has also arrived with the firefighters, and the ambulance needs to find the shortest path to the nearest hospital, which is here in the northern area of the city. So let's have a look on these things first.
How will the firefighters receive this information?
That's a question of integration, and this is something we need to discuss in each five. Basically, we can send these routes as a JSON file through an API to whatever we ask for. But yeah, for now, we are presenting this in the graphical user interface of our software. But all of those things you see here can be accessible through API. So then we can connect it to basically any other graphical user interface we want.
Alright, so now let's shift the time. As you can see, the traffic is changed. So now we are not actually finding the fastest path, but we are prognosing the fastest path. So, and yeah, I'm using like I did this yesterday, so I have like afternoon hours, but it doesn't matter if there will be the morning phase or the afternoon for this purpose. So if, again, we need to prognose. So now we made the time tick, and now so the model was recalculated again, and now it's doing now it's based on the prognose data. So again, this way we have calculated the shortest path or the fastest path to the nearest medical facility. And as you can see, again the same sort of a decision-making problem, which path to choose, whether to avoid the roadworks or go slightly longer by distance, take the slightly longer road to get to the medical facility. And yeah. So basically, just to conclude, there are like steps of the emergency situation is triggered. That means that there is, and it's during the digital breakdown. That means that there is a need to find the optimal path to the area of interventions. For us, it means to implement the traffic management measures that I showed you, like ban the turns and close the roads to prevent the incoming traffic. Then to run the transport model calculations. That means calculate the reassign the traffic, reshuffle it, and then calculate the shortest path to the emergency area, and then calculate shortest path again from the emergency area to the nearest hospital. Yeah, and one more thing, last one, there is a functionality to show you the visual comparison of the scenario with the base model. So go this way, you can see what the traffic measures are, how traffic measures are impacting the event.
This is basically why we think that using the model is beneficial, because once the model is fed up both from the very last information about the traffic and the information from something we called in this SPARROW cities common operational picture, like from the area of the event, then the traffic is really different than what you can get in such a situation from navigations and such kinds of a tool. And moreover, it also do the short-term predictions, which we don't have ready yet, but we are about to have. And in this case, like, we can plan ahead, like next 20-30 minutes, what the traffic probably should look like, and be ready for that. So this is our idea how to connect this one small technology into the present scenario. And yeah, this is, I guess, all for us.
Yeah, this is our and the same situations is they described in the slides. So,
Thank you.
I have a question.
No,
Yes.
So in one of the scenarios, you've shown like